Hello, hello, hello everybody, and welcome back. In this video, we're looking at the second to last question, question number 24, on the 2011 Cayley that we've been working through. Dolly, Molly, and Polly can each walk at 6 kilometers per hour. Their one motorcycle, which travels at 90 kilometers per hour, can accommodate at most two of them at once, and cannot drive by itself. Fair enough. Let T hours be the time taken for all three of them to reach a point 135 kilometers away. Ignore the time required to start, stop, and change directions. What is true about the smallest possible value of T? So the smallest possible value of T. So getting everyone there in the least amount of time. So we want to be as efficient as possible. And then we've got, as answers, we just sort of have ranges of values here, I guess. Now this question, I think it's exactly the same. It was a question, might have been question 25 on this year's Pascal as well. So if you want to go watch that video as well, I seem to recall I screwed up a bunch of the calculations, but I got the answer in the end. But if you want to watch it to see me maybe do it a different way, I can't remember exactly what I did here. I know that we want to be sort of as efficient as possible. If we want to have the smallest time, we have to sort of have everybody be doing their part. Okay, there's lots of sort of ways you could imagine that they sort of get from point A to point B. I mean, you could just sort of ferry someone with the motorcycle, come back, pick up the last person. That's one way to do it. That's grossly inefficient. And efficiency definitely is the name of the game here. So I think the best way to go from start to finish, we don't want anyone to not be moving at any given time. So with that in mind, so we'll start with Dolly, Molly, and Polly. So we'll put Dolly and Molly on the motorcycle, and they'll travel out to a certain point. But Dolly is not going to take Molly all the way to the end, because then there's going to be a period of time where Molly's just sitting there doing nothing. And if she takes her all the way to the end, then that increases the time it takes her to come back to get Polly. That's going to be a waste of time. So what we're going to do is we're going to have Molly be dropped off at some point before the end. I don't know exactly what point. We'll say a distance m from the end. Okay, so they've gone a distance 135 minus m. Now in this time, Polly will have gone a certain distance as well. Okay, how far exactly, we can work that out in terms of m in just a moment. But the point is, so Dolly's going to drop off Molly, and then Molly from then on out is just going to walk towards the end. Okay, and what we're going to do is we're going to time it so that Dolly comes back, picks up Polly wherever they happen to meet, and then comes all the way to the end, and everybody gets there at the same time. So that's how we're going to work this. That way everybody's in motion. Molly's constantly walking when she's not on the bike, Polly's walking when she's not on the bike, and Dolly's just driving and ferrying in between the two. Okay. So what happens? So in the time it takes Dolly and Molly to drive on the motorcycle 135 minus m, Polly will have gone, we could call this distance p if we want. Polly goes 135 minus the m kilometers that will work. We'll figure out what m is supposed to be later. Divided by 90 kilometers per hour. That's how long she's been walking. And she walks at 6 kilometers per hour, just like Molly does. Okay. So 90 divided by 6 is 15, so we get 135. 135 divided by 15 should be 9. So 9 minus m over 15 kilometers. Okay, so that's how far Polly goes. That's where she is when Molly gets dropped off. And then Molly's going to walk this remaining distance m, whatever it is. And now between m and p, so Polly has... Let's draw another picture. So Molly starts walking. Here's m. Polly's still here. Polly's going to keep walking this way, but Dolly, having dropped off Molly, is going to come back to get her. And so they're closing this distance between the two of them. 135 minus m minus the distance that Molly has already gone. That should be 126 minus 14m over 15. So they're going to go that, they're going to close that gap at 96 kilometers per hour. That's how long it takes for them to meet. And they'll meet somewhere here. And in that time, how far has Polly gone? Well, Polly goes at 6 kilometers per hour. 96 over 6 should be over 16. 126 does not divide 16, I'm pretty sure. No, sadly it does not. 126 minus 15 over 5, or 14 over 15m, all over 16. And so that's how far she's gone. And then we have to make this distance up, and we'll be going at 90 kilometers per hour. So, how much distance is left? I can see why on the Pascal I might have screwed up some calculations, because there's a lot going on here, a lot to try and keep track of. 126, what's 126, what's the biggest factor with 2 you can get there? 2, just divide by 2, okay. So, to recap, what's been happening? Polly went 9 minus m over 15, and then has gone 63 over 8 minus 14 over 2, so it should be 7 over 120m. There's this distance m. And so now what do they have left to go? 135 kilometers minus the 9 minus m over 15 minus 63 over 8 minus 7 over 120m. So they have to go that distance at 90 kilometers per hour. And how long... And then I want them to arrive at the same time Molly does. That way no one has wasted any of their time. Everybody gets there at the same amount of time. However, Molly's been walking. So Molly was walking for this entire time at that same speed. So Molly has also gone this distance. So Molly has also gone 63 over 8 minus 7 over 120m and has a certain distance left to go. So the girls on the motorcycle cover this distance at 90 kilometers per hour. Takes them some amount of time. And I want that to be the same amount of time as Molly covers this distance at her 6 kilometers per hour. Okay, so that shouldn't be so bad. Multiply both sides by 90 and we can get a 15. 135, I'm going to do minus 9 and then plus m over 15. Oops. Minus 63 over 8. Plus 7 over 120m. Needs to be equal to 15m minus 63 times 15, 945 over 8, minus, so plus 7 over 120, but we multiply by 15, so plus 7 over 8m. Okay. That's a lot, but let's get all the numerical values onto one side. 135 minus 9, we already said that's 126. Minus 63 over 8 plus 945 over 8. That should be 15m plus m over 15 plus 7/8 m minus, well, this should be a minus as well, minus 7 1/20 m. All right, 945 minus 63 sadly is not a multiple of 8. Darn. Really hoping it was. What could we do? I suppose we could multiply both sides by 8. 126 times 8, 1008, minus 63 plus 945. 120m, 8m over 15, plus 7m minus 7 over 15m. I like that because those two will now combine to a minus m. So I get 126m. And then 1008 minus 63 plus 945 is 1890. Divide that by 126. Well, look at that, m is 15. Okay, now, what did we want? We want the total time. Yeah, t in hours. That's what they're talking about. But now I completely understand the situation. We drop Molly off 15 kilometers from the end. She walks. So how long does it take to drive Molly 15 kilometers from the end? Well, they'll be going 120 kilometers at 90 kilometers per hour. So that'll be 4/3 of an hour. Okay. And then plus, how long does it take Molly to walk the remaining 15 kilometers? Well, she walks 15 kilometers at 6 kilometers per hour. So that should be 5 halves an hour. So 4/3 plus 5 halves. That'll be 8 plus 15 over 6. So 23 over 6 hours. I think should be our answer. And 23 over 6 is 3.83333. Because they want decimals. And what category does that fit into? A here, which I already happened to circle just because I was trying to circle this T a moment ago. But that's okay. We get our answer A. And we definitely know we can't improve on this because that's the smallest of the ranges they give us for options. So there we go. Our answer here is going to be A. Fantastic. All right, just one more question remains. Question number 25. I would encourage you to try it out if you haven't already. Thank you guys so much for watching, and I'll see you for question number 25 next time.